Right then, let's talk about our home planet, Earth. Imagine you're on a merry-go-round at a carnival. If it spins in a nice, smooth circle, you can wave to your friends, enjoy the ride, and not feel too dizzy. That, in a nutshell, is Earth's orbit around the Sun. It's not a perfect circle, mind you, but it's very close. Scientists call this shape an ellipse, but Earth's version is so slightly squashed that it's almost circular. This near-perfect loop is one of the key ingredients, a secret sauce, if you will, for why life as we know it can thrive here. It keeps our distance from the Sun remarkably consistent throughout the year. This consistency is absolutely crucial. Because we stay at roughly the same distance from our star, the Sun, we receive a steady, reliable supply of heat and light. Think of it like sitting near a campfire. If you stay in one spot, you get a constant, comfortable warmth. If you were constantly lunging towards the fire and then leaping away, you'd be either scorching your eyebrows or shivering in the cold. Earth's stable orbit means we avoid these dramatic temperature swings. This cosmic stability has allowed life to evolve over billions of years, creating the incredible biodiversity we see today, from the smallest microbe to the biggest blue whale. Now, a common misconception is that our seasons, summer, autumn, winter, and spring, are caused by our distance from the Sun. Not so. The real reason for the seasons is Earth's tilt. Our planet is tilted on its axis by about 23.5 degrees, like a spinning top leaning to one side. Now let's turn our gaze to the red planet, Mars. If Earth is on a smooth merry-go-round, Mars is on one of those rickety, old-fashioned roller coasters with a lopsided track. Its orbit is much more elliptical or eccentric, as astronomers say. This means its path around the Sun is a noticeably squashed oval. Mars doesn't just get a little closer and a little farther from the Sun. It takes a real plunge towards it and then swings way out into the colder depths of space. Well, at its closest point to the Sun, perihelion Mars is about 206 million kilometers away. But at its farthest point, aphelion, it swings out to a whopping 249 million kilometers. That's a difference of over 42 million kilometers. This huge change in distance means that the amount of solar energy Mars receives varies dramatically throughout its year. When it's closer, it gets about 45% more sunlight and heat than when it's at its farthest point. This orbital wobble has a profound effect on the Martian seasons. Just like Earth, Mars has a tilt, about 25 degrees, very similar to ours, which is the primary driver of its seasons. However, its eccentric orbit supercharges them. When the southern hemisphere of Mars is tilted towards the Sun and the planet is at its closest approach, it experiences a short, intensely hot summer. Conversely, when it's tilted towards the Sun, but the planet is at its farthest point, it has a long, cool summer. This isn't just a curious astronomical fact. It drives the planet's wild weather, including the colossal dust storms that can sometimes engulf the entire globe. Let's do a bit of cosmic tinkering. Imagine we could grab Earth and place it onto an orbit with the same shape as Mars is. We'll keep our average distance from the Sun the same so we don't completely freeze or fry, but we'll adopt that Martian eccentricity. What would our new annual journey look like? Our planet would no longer be on a gentle merry-go-round. Instead, we'd be strapped into a cosmic slingshot. Let's put some numbers on this new wild ride. Our current orbit keeps us between 147 and 152 million kilometers from the Sun. With a Martian-like eccentricity, our closest approach, the new perihelion, would be around 138 million kilometers. That's about 9 million kilometers closer than we are now, putting us in a serious cosmic hot seat. Conversely, our farthest point, the new aphelion, would be way out at 166 million kilometers. That's a full 14 million kilometers farther than our current aphelion. The total variation in our distance from the Sun would balloon from a tiny 5 million kilometers to a staggering 28 million kilometers. This new trajectory would mean the amount of solar energy reaching us would fluctuate wildly. This isn't just a minor tweak to our planet's energy input. It's like cranking the thermostat up to full blast for a few months and then turning it way down. According to Kepler's laws of planetary motion, a planet moves fastest when it's closest to the Sun and slowest when it's farthest away. With Earth on this new eccentric path, our seasons would be completely rewritten. Remember how our seasons are currently governed by our 23.5-degree tilt. That tilt would still be there, but the massive new variation in our distance from the sun would add a powerful and chaotic second driver. Imagine the northern hemisphere is tilted towards the sun, which should mean it's summer. If this happened while Earth was at its closest point to the sun, perihelion, it would trigger a super summer. The direct sunlight from the tilt would be amplified by the intense radiation from being so close. Temperatures would soar to unbearable, record-shattering highs. Deserts would expand, forests would become tinderboxes, and heat waves would be not just dangerous, but potentially unsurvivable in many regions. 6 months later, the northern hemisphere would be tilted away from the sun and be at its farthest point, aphelion, creating a super winter of unimaginable cold, with glaciers advancing and ice sheets expanding. But the southern hemisphere would experience the exact opposite. While the north was enduring its scorching super summer, the south, tilted away from the sun but still at perihelion, would have a surprisingly mild, short winter. The length of these new seasons would also be warped. This means the intense super seasons, the scorching summer and the mild winter, would be brutally short and fast. The planet would whip through this part of its orbit in a frenzy. This uneven timing would wreak havoc on everything from farming cycles to animal migration patterns, which are all finely tuned to the current, even-paced length of our seasons. The predictable 4-season cycle that billions of people depend on would become a thing of the past, replaced by a year of jarring and unpredictable extremes. The new extreme seasons would inevitably lead to extreme weather on a scale we can barely comprehend. Our planet's weather is essentially a giant engine, powered by heat from the sun, that moves energy around from the hot equator to the cold poles. During the short, scorching super summers, the immense heat would cause massive amounts of water to evaporate from the oceans. This water vapor is the fuel for storms. We would see the birth of colossal hurricanes, or hypercanes, far more powerful than the Category 5 storms we see today. Inland, the intense heat would lead to prolonged and devastating droughts. Vast agricultural breadbaskets could turn to dust, and massive, uncontrollable wildfires would rage across continents, fundamentally reshaping landscapes. Then comes the big swing. As Earth careens away from the sun towards its deep freeze winter, the dramatic temperature drop would create enormous atmospheric pressure gradients. This is the perfect recipe for generating powerful winds. We could see the emergence of continent-sized storm systems, not unlike the global dust storms on Mars. Blizzards would become epic events, burying entire cities under meters of snow. Even the oceans would not be spared. Ocean currents like the Gulf Stream act as a global conveyor belt carrying warm water to cooler regions and vice versa, and are critical for regulating our climate. The new extremes could disrupt or even shut down these vital currents. For humanity, life on this new, wobbly Earth would be a perpetual struggle for survival. Our entire civilization, our cities, our agriculture, our infrastructure, is built on the assumption of a stable climate and predictable seasons. This new reality would shatter that foundation. The places where billions of people currently live might become uninhabitable. Coastal cities like New York, Shanghai, and Mumbai would face a double threat: catastrophic hypercanes during the super summer and the relentless advance of sea ice during the deep freeze winter. Agriculture, the bedrock of our society, would be thrown into chaos. We would need a complete revolution in agriculture, perhaps moving food production indoors to massive, climate-controlled vertical farms. Human societies would likely become migratory. People living in regions with the most extreme seasonal swings might be forced to move twice a year to survive. Imagine entire populations trekking from scorching equatorial zones to more temperate latitudes to escape the supersummer, only to have to migrate back again to escape the encroaching ice of the deep freeze winter. Our settled urban way of life would likely give way to a more nomadic existence, driven by the harsh whims of our new orbit. The psychological and cultural impact would be profound. The rhythm of life, so deeply connected to the gentle turning of the seasons, would be broken. We would be a species perpetually on edge, forever adapting to a planet that no longer felt like a stable, nurturing home, but rather a hostile and capricious force. The animal kingdom, with its intricate web of life tuned to Earth's current rhythms, would face an existential crisis. Many species have evolved highly specific strategies for survival that are directly tied to the predictable timing of our seasons. Think of migratory birds that travel thousands of kilometers, guided by the changing length of days, to find food and breeding grounds. On our new Earth, their internal clocks would be completely scrambled. Animals that hibernate, like bears and groundhogs, would also be in deep trouble. A bear might emerge from its den too early, finding no food available, or it might not have enough stored fat to survive a winter that drags on for months longer than expected. Ocean life would be equally devastated. Coral reefs, the vibrant rainforests of the sea, are incredibly sensitive to temperature changes. The extreme heat of a super summer would cause massive, irreversible coral bleaching on a global scale. The very chemistry of the oceans would be altered, impacting the plankton that form the base of the entire marine food web. The symphony of life in our oceans would fall silent. Ultimately, this new, harsh reality would trigger a mass extinction event. The rich biodiversity that makes our planet so special would be decimated. The world would become a much quieter, less vibrant place, dominated by a few hardy survivors in a constant, desperate struggle against a planet that had turned against them. Contemplating an Earth with a wobbly, Mars-like orbit is a sobering exercise. It takes us on a journey through a world of climatic chaos, ecological collapse, and a desperate struggle for survival. This thought experiment does more than just explore a hypothetical scenario. It shines a brilliant spotlight on the extraordinary luck of our current situation. It reveals that the stability and vibrancy of our world are not a given. We are living on a Goldilocks planet in more ways than one. We talk about being at just the right distance from the sun for liquid water to exist, but we must also talk about being in an orbit that is just right. This orbital stability has provided the long-term, predictable environment necessary for life to not only emerge, but to evolve in all its magnificent complexity. It has given us the gentle, reliable seasons that have allowed humanity to flourish, to build civilizations, to develop agriculture, and to ponder our place in the cosmos without the constant existential threat of a climate gone mad. This cosmic perspective should fill us with a profound sense of gratitude. Our planet is not just a rock with water on it. It's an incredibly fine-tuned system, a rare and precious jewel in the vast, dark expanse of space. The gentle tilt of its axis and the steady, near-circular path of its orbit are gifts of celestial mechanics that we often take for granted. They work in tandem to create the world we know and love. A world with whispering spring breezes, warm summer sun, crisp autumn air, and quiet winter snows. So, the next time you look up at the sky, think about the immense silent journey our planet is on. We are all passengers on this giant blue and white spaceship, traveling at 107,000 kilometers per hour on a path of incredible stability. Our world's gentle ride is a profound stroke of luck, a cosmic jackpot. Understanding how different things could be teaches us the most important lesson of all. Our home is a fragile, beautiful anomaly. It's the only one we have, and it is our duty to appreciate, understand, and protect it.